Let's now talk about square roots. So first of all, we need to understand what are square roots. Now, for a perfect square, the number whose square it is, that number is called the square root of the square number. Say for example, we have a number 9, and 9 we know is the square of 3. So the square root of 9 will be 3. So it's basically, square root is basically an inverse operation of square. For example, we have subtraction, which is an inverse operation of addition. We have division, which is an inverse operation of multiplication. Similarly, square root is an inverse operation of square. Now we take an example here. We have 2 square is equal to 4. So 2 is basically, this 2 becomes the square root of 4. And it is represented by the symbol square root of 4 is equal to 2. Now, where are the square roots basically used? They're used where, supposing the area of a figure is given to you and we need to find out the side of that figure. Now, the example that we know is square is basically the area of a figure square whose side is given. So now if in case if we have a reverse operation to be done, if we provided with the area of the square, we need to find out the side of that square. We can just do that by finding the square root of the area. And similarly, it is used for other higher order mathematical calculations like standard deviations, geometric mean, etc., which we'll be studying in the higher classes. And one important thing to know is that since the square of both a positive and the negative number with the same value is the same, so we know that 2 multiplied by 2 is also 4, and minus 2 multiplied by minus 2 is also 4. Similarly, if we take any number, for example, we take 3, we know that 3 multiplied by 3 is 9, and similarly is minus 3 multiplied by minus 3, that will also be equal to 9. So we can say that square root of 9 would be both 3 and minus 3. So this is important to understand, that the square root of any square number will have two values, with the absolute value remaining the same. Both the positive and the negative numbers will be the square root of the given square number. Now let's see how to find the square root of a given square. We know that the square of a natural number n is equal to the sum of first n odd natural numbers. So if we subtract the odd natural numbers starting from 1 from the given square till the time we get a 0, we'll be able to find out the square root of the given number, right? So what we do is, we'll then count the number of subtractions which we've done, or the number of odd natural numbers that we've subtracted to get a final 0. That will give us the square root of the given square. So let's see that how do we do that. Now supposing we need to find out the square root of 25. We start with subtracting 1. We need to subtract first n odd natural numbers. So we subtract 1, we get 24. Then we subtract 3, we get 21. We subtract 5 and we get 16. We subtract 7 and we get 9. We subtract 9 and then we get a final 0. So we need to count how many first odd natural numbers have we subtracted. So we've subtracted 1, we've subtracted 3, we've subtracted 5, we've subtracted 7, and we've subtracted 9. So we have total 5 odd natural numbers that we've subtracted. So square root of 25 is 5. Now this is a very time consuming approach, and it is not practical for specifically the big numbers. Now what is the other way to find square root of a given square? Now we can do that by prime factorization. Now since a square number is a number multiplied with itself, so we know that every factor in a square number will appear 2 times, minimum of 2 times, or you can say a multiple of 2 times. Say for example, we have 6. The factors of 6 are 2 and 3. And then if we take the factors of 36, the factors will be 2 times 2 and 2 times 3. So it will be, because for 6 the factors were 2 and 3. So the factors for 36 will be 2 and 3, 2 times each. Right? So now we'll first find all the prime factors of the given number. All the prime factors of the given number. So for 36 we found all the prime factors and we'll pair them. So in this case we'll pair them to make this is one pair and this is the other pair. If there is any prime factor which cannot be paired, then the given number is not a perfect square. So in this case, if we see 36, we know that all the prime factors have been paired together. So this is a perfect square. If we take another example, we'll take an example of number 48. So if we find the prime factors of 48, we have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. So now this gives us 48. Now if in this we start pairing, we know that this is one pair, 2 and 2. This is another pair of 2 and 2. But this is not paired. So that means 48 is not a perfect square. Now if all the prime factors have been paired together, then we take one factor from each pair. So in case of 36, we know this is one pair, 2 into 2 is one pair, and 3 into 3 is one pair. So we take one factor from each pair. So we take 2 from this and 3 from the other one. Then we multiply them and we get 2 multiplied by 3 as the square root of the given number 36. Now this approach can be used to find square roots of only perfect squares. Now we just saw that for 48, if we want to find out the square root, we've not been able to find out square root of 48 using this approach because 3 is not existing in pair. We just talked about the method of finding square root using prime factorization, but that method is a very lengthy method if specifically for finding square root of large numbers. So instead of that method, we have another method which we use for finding the square roots, which is the square root by division. So in this method, we take the number and we place a bar over every pair of digits starting from the units place. The leftmost bar could either have 1 digit or 2 digit depending upon the number. So now we'll see that with the help of an example. Now let's take a number 625 and we place the bars over every pair of digits starting from the left. So 25, on 25 we place one bar and the leftmost bar only has one digit in this case. Now we find a number whose square is just less than the number in the leftmost bar. So leftmost bar has 6 in this case. So we have 2 square which is 4, which is just less than 6, and if we see 3 square it becomes more than 6. So we'll not take 3, we'll take 2 here and we'll place 2 over here and 2 in the quotient area. Now we multiply 2 with 2 and we place 4 below the number in the first bar and we subtract the 2 and we get 2 here, and we bring, just as we do in the standard division, we bring the next in the normal division we get just one number down. In this case we'll get the number in one bar in the same go. So we'll get 25 here. So we get 225 here. Now we'll take double of the quotient and we place over here, which is 4, double of 2 is 4, and we place a blank besides 4 and in the quotient. So now there's a single digit that needs to be placed at both the places, and we find out that digit in such a way that if that digit is multiplied by this number, that should be either equal to or less than the number which we have over here. So in this case, if we place a 5 over here, we have 45 here, and that needs to be multiplied by 5. So 45 multiplied by 5 becomes 225, which is equal to the number present here, and we are left with no remainder. So now this 25 that we have in the quotient is the square root of the given number, which was 625. Now let's take another example. We take an example of a number which is 4 digit. Let's take 1024. Now when we place the bars starting from the units place, we place a bar on 24 and we place a bar on 10. Now if we see the number whose square is just less than 10 is 3, because 3 square is 9, and if we take 4 square it becomes more than 10. So we'll take 3 in this case and we'll put 9 below 10 and we'll subtract it. So this becomes 1. And again, as in the previous example, we'll bring the 24 down. And here we take double of the quotient, which is 3. So it becomes 6, and we place a dash along with 6 and in the quotient area. So if we now see, we take a digit 2. 62 multiplied by 2 becomes 124. And if we subtract, we get a 0. So this again means 32 is the square root of 1024. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.